So now we also need to consider amphiprotic species. So amphiprotic species can act as both an acid and as a base. So as we mentioned before, water, that can act as either an acid or a base, which makes it an amphiprotic species. We also have a few other examples. So we've got hydrogen carbonate ions, hydrogen sulfate ions, and dihydrogen phosphate ions. So in the presence of an acid, these can act as a base, and in the presence of the base, they can act as an acid. And so this is because they have a charge on them. And so because they have a charge, they have the capacity to be accepting a proton because they want to attain a stable octet. And so by gaining a proton, they can then no longer have a charge, no longer be ionic, and become a stable molecule. So for example, hydrogen carbonate ions can gain a proton to become hydrogen bicarbonate. Then you can have hydrogen sulfate ions, which can form dihydrogen sulfate if they gain a proton. And then you've got dihydrogen phosphate ions, which can then form phosphoric acid if they're to gain a proton. However, you can do the opposite, where in the presence of a base, these can act as an acid, and so hydrogen carbonate ions can lose their proton to become carbonate ions. Hydrogen sulfate ions can lose their hydrogen to become sulfate ions. And dihydrogen phosphate ions can lose one of their hydrogens to form hydrogen phosphate ions, and then can undergo this reaction again to form just phosphate ions.